All right, good afternoon, ladies and gentlemen. We're going to be going over the 2019 AP Calculus AB multiple choice exam. First up, we got 30 questions. Multiple choice, again, no calculator. So number one, the integral of x squared divided by 4. Okay. Before I do the integral, I want you to know that the denominator of 4, you can factor it out and think of it as a constant, 1/4 times x squared dx. This makes it easier to work with because the 1/4 is something you don't have to worry about. We're going to focus on getting the antiderivative for x squared. So you're going to add 1 to the exponent and divide by the new exponent. Plus c. Don't forget the plus c. Put it all together, and we get 1 over 6 x to the power of 3 plus c. Oh, silly me, there's a mistake. It was a 1/4 and I wrote a 1/2. No wonder I couldn't see the answer. It's 1 over 12 x to the power of 3 plus c. We got b. Which of the following is an equation of the tangent line? In order for me to write the tangent line, we're going to have to find the slope, and we need a point. To get the slope, we're going to get the derivative of cosine, which is negative sine. Then we're going to go and plug in our pi over 2. Negative sine of pi over 2. That's going to be -1. There's your slope. To get the point, plug in the pi over 2 to the cosine, which is 0. So the point is pi over 2 comma 0. Señoritas, need you to be silent, please. I hear you all the way over here. Okay, so now for my tangent line. Y equals m, x minus x1 plus y1. So this is going to be -1 times x minus pi over 2 plus 0. If I distribute the negative, the answer here is C. Okay, the derivative. For this problem, we're going to have to use the chain rule, and we're going to have to use it. Well, there's 3 functions here. Okay, chain rule. So we're going to take the derivative of the outside. You leave the inside alone. The new exponent is now going to be a 1 times the derivative of the inside, cosine of the square root of x. You leave the inside alone. Times the derivative of the square root of x. And the square root of x, remember, it's x to the power of 1/2. So we bring the 1/2 down, and we subtract 1 to the exponent. Okay. And when we clean this up, we get 4 times 1/2 is a 2. So we have 2x to the power of -1/2 times sine of the square root of x times cosine of the square root of x. Let's take a look. And the answer here is D. Okay, finding the integral, the antiderivative. Since this antiderivative looks a little complicated, we're going to be using u substitution. Okay, u is going to be the function that's on the inside. So x to the power of 3 plus 3x minus 5. My derivative is 3x squared plus 3 dx. But everything is kind of grouped together. Then, as you know, we're going to go ahead and divide. We're going to isolate the dx, leaving us with du divided by 3x squared plus 3 is equal to dx. And now I'm ready to go back to the integral. The integral of x squared plus 1 divided by u to the power of 3 times 1 over 3x squared plus 3 du. Now, normally when you do u sub, we can already cancel out any common terms, but right here, we don't really have any common terms unless you factor out a 3, or technically a 1/3. We're going to factor out a 1/3. We're going to factor it out from this guy right here. And it's going to be 1 over x squared plus 1. That's going to allow me to cancel out the x's. Okay, so now this equals 1 over 3, the integral of 1 over u cubed. But we're going to go ahead and bring it up to the numerator so we can do our antiderivative already. Okay, so we're going to add 1 to the exponent, and we're going to divide by the new exponent. And don't forget the plus c. So now, the 1/3 times the negative 1/2, it's going to be negative 1 over 6. The u is going to come down to the denominator. And the plus c, we're just going to write it as plus c, right? It doesn't matter that you distribute a constant to it. Okay, what did we choose for u? Let's see. Oh, it was a 3x squared plus 3. So my u is 3x squared plus 3 squared plus c. Let's take a look at our answer choices. What, these doesn't have a negative 1/6. 3x squared plus 3 plus c. The answer is B. Hold on. No, I was looking at the wrong thing. That wasn't my u. My u was this guy. That's what I get for not zooming out of my work completely. Let me fix this real quick. It was x cubed plus 3x minus 5 to the power of 2 plus c. So I stand corrected. The answer is actually D. Okay, the function f is given on what intervals is the graph concave up. So for concavity, we're going to have to find the second derivative. And the first derivative is 12x squared minus 4x to the power of 3. My second derivative is 24x minus 12x squared. We set it equal to 0. And I'm going to go ahead and factor out a 12x. Here we go. Separate them and set each one of them equal to 0. And there we go. There's our two critical points. But we want have f. We want f to have a positive concavity, right? So that means the second derivative has to be positive. So take your number line, place your critical points, and now pick some values within each interval and plug them into the second derivative. My second derivative, I'm going to be using the factor form of the second derivative because it's always easier to handle. Watch. If I plug in the negative 1 into my second derivative, I'm going to get negative 12 times 2 minus negative 1. That's a positive. But ultimately, we get a negative. Okay, I can also plug in the 1. 12 times 1 is positive. 2 minus 1 is positive. So we get positive. Lastly, we're going to go ahead and plug in something greater than 2. 12 times 3 is positive. 2 minus 3 is negative, which gives us a negative. So f of x is concave up on the interval from 0 to 2. Okay. Find the derivative at the point 2, 8. All right, so the derivative here is 1 plus 3 times 1/3 y. Subtract 1 from the exponent, which is now negative 2/3. But because we're doing the derivative with respect to x, that means we have to do the chain rule and find the derivative of y. And that's y prime equals y prime. Okay. Now I'm gonna make it simple on myself, and I'm gonna go ahead and plug in my values already. So y is 8 times y prime is equal to y prime. Now the way you're gonna handle 8 to the power of negative 2/3, think about it this way. It's gonna be 1 divided by the cube root of 8 squared. Now it's much easier if you take the cube root first, if possible. And luckily we know what the cube root of 8 is, right? 2 times 2 times 2 is 8. So we have 2 squared. 1 over 2 squared is 1/4. Subtract the 1/4 y prime on both sides. And that's going to be 3/4 y prime. And then at the end of the day, we're going to multiply by the reciprocal, multiply both sides by 4/3. And that's our slope. The answer here is D. Okay. Another derivative, a simple derivative if you guys know your rules. So for the first one, we're going to get 5x to the power of 4. That's a straightforward one. And just by knowing that, we can already cancel out a. Now the derivative of 5 to the power of x, that derivative is 5 to the power of x times ln of 5. That's just a derivative you guys have to know. So here it is. The answer is A. Here's your notes. The derivative with respect to x of a to the power of u, where u is a differentiable function, is a to the u ln of a, and then you would multiply it by the derivative of u prime, aka the chain rule, du dx. But in this case we had an x, and the derivative of that is just 1, so it didn't really matter. The limit as x approaches infinity. Okay, when you're taking the limit to infinity, you're gonna look at the power functions. You're gonna look at the functions that grow the fastest. So we're gonna go ahead and ignore the 10 and the 5, and we're gonna stick with negative 6x squared divided by 3e to the power of x. Now you could technically simplify it into negative 2x squared over e to the x, but at the end of the day, you have to know which one of them grows fastest. And the quadratic one, in this case, is the small one, and the exponential one is the big one. And every time you have small over big, the limit's going to be 0. Okay, number 9. The region R is bounded by the graphs of 2x and 4x minus x squared. What is the area of R? If I want to find the area of R, we're going to do the integral from a to b, top minus bottom dx. But you have to figure out which was the top and the bottom. Okay. Oh, and not only that, we also have to find our limits of integration. We're going to do this by setting the functions equal to each other. That's where they're going to intersect, right? Whenever they're equal to each other. So we have 2x minus x squared. Thank you. I can factor out an x. It should be 2 minus x. Set each factor equal to 0. And solve for your critical points. The first one's already there. And then this one's going to be 2 is equal to x. There's your 2 critical points. Or sorry, not critical points. Your points of intersection. So next, we have to figure out which function is the top function and which function is the bottom function. So since my interval is going to be going from 0 to 2, we're going to go ahead and plug in something in between those two, such as 1. So we're going to check x equals 1. If I plug in 1 into the first function, we get a 2. And if we plug in a 1 into the second function, we get a 3. That right there will automatically tell you which one's the top function and which one's the bottom function. Because 3 is higher, that makes this the top function, and 2x becomes the bottom function. So the area, the integral from 0 to 2 of the top function minus the bottom function dx equals the integral from 0 to 2 of 2x minus x squared dx. This equals x squared minus 1 over 3 x to the power of 3, evaluated from 0 to 2. And I'm going to go ahead and start plugging in the values, right? So 2 squared is 4. 2 cubed is 8. 0 squared is 0, and 0 cubed is 0. So now we have 4 minus 8 thirds. To complete the problem, we're going to have to get a common denominator. So the 4, if you multiply it by 3, you're going to get 12 over 3. Don't forget there's an invisible 1. And then 12 thirds minus 8 thirds, that's 4 thirds. The answer is B. Okay. The graph of f is shown below. G is the function defined by g of x. What is the value of g prime of 2? Okay, so we're going to start by finding the derivative. The derivative of g is found through the quotient rule. And the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, and now if I plug in my 2, g prime of 2, that's going to be f of 2 times 4 minus 4 plus 1, that's 5, f prime of 2 divided by f of x, so in other words, f of 2 squared. Okay. F of 2, according to the graph, f of 2 is 3. And then f prime of 2 is going to be the slope at 2. And because we have a linear function, we can actually calculate the slope pretty easily by doing rise over run. 1, 2, 3, 4. The rise is 4, the run is 1, the slope is 4. F of 2, we said that was 3, so 3 squared. That gives us 12 minus 20 over 9, which is negative 8 over 9. Okay, now this integral. This integral looks a little complicated because it's a quotient, right? You might be automatically thinking, oh, I got to do u sub. Or maybe there's a derivative that I know. But you don't have to do any of those things. The best thing to do for this problem is to simplify. X squared divided by x minus x divided by x. Okay. This is going to simplify to x minus 1. And now you can actually find the antiderivative pretty easily. We have 1/2 x squared minus x evaluated from negative 1 to 1. And that gives us 1/2 minus 1 minus 1/2 times negative 1 squared minus negative 1. Really careful with all the parentheses, because we're dealing with a lot of negatives here. These two give me negative 1/2. Then I get positive 1/2 plus 1. 1/2 plus 1 is 3/2, and 3/2 minus 1/2 gives me negative 4/2. So the answer here is -2. The table above gives me values for a differentiable function f. Which of the following intervals must be a number c such that the derivative is 2? In which of the following intervals? Okay. So because the derivative has to be 2, that's talking about the slope, right? And according to the mean value theorem, if a function is differentiable, then the average rate of change should equal to the instantaneous rate of change at some random location. And we already know what the slope is, right? We know the slope is 2. So we just have to check all the intervals one by one and check for A, is the slope 2? Well, if I do f of 4 minus f of 0 divided by 4 minus 0, we get 0 minus 8 divided by 4. And no, the slope is not going to be -2. So that's the thought process, right? So if I skim through all of these, I want to make sure my numbers are increasing. So maybe the answer is going to be right here because the function increased, right, from 2 to 10. So let's see. C. F of 12 minus f of 8 divided by 12 minus 8. That's going to be 10 minus 2 divided by 4, which is 8 over 4, which is 2. That checks out. The answer is C. But if you didn't know that, you're just going to have to check all the intervals one by one. And once again, I knew that it was going to be C because here the function increased. Look. Since the value went from 2 to 10, that means the derivative is positive. And my derivative is, in fact, positive. From 0 to 4, the slope here, the derivative, is negative. So that wasn't going to work. From 4 to 8, the slope is positive. So that could have been a contender. And from 12 to 16, the function decreased, which means the derivative was negative. That was not going to work. So A and D were not going to work automatically. Okay, the limit as x approaches 0. If you plug in 0 from the beginning, we're going to get sine of 0 divided by e to the power of 0 minus 1. And we get that it doesn't exist. But is this really the limit? Well, the only way to know is to use L'Hopital's. And if I use L'Hopital's, I take the derivative, then I can plug in my 0. Cosine of 0 is 1, e to the power of 0 is 1, so the limit here is 1. You can only use L'Hopital's if you get 0 over 0, or if you get infinity over infinity. Those are the only two conditions where you can use L'Hopital's. Okay. The particle moves in a straight line. The acceleration is a of t. At 0, the velocity is 2. The position is 5, which is an expression for the position. Okay. So I know my acceleration is 12t. So that means my velocity is the antiderivative, 6t squared plus c. If I plug in 0, I use my initial condition. I know the velocity is 2, which means c is equal to 2. And this gives me the complete velocity equation. We have 6t squared plus 2. Now from the velocity equation, I can go ahead and find the position function by finding another antiderivative. So now I have 2t cubed plus 2t plus c. Once again, we plug in the initial condition. And the position of the particle is 5. So my position function is 5. Or not 5, but 2t cubed plus 2t plus 5. There we go. D. Okay, we have a piecewise functions. Which of the following statements is true? The function is continuous and differentiable. Well, I'll tell you one thing. If something is differentiable, then that means it's going to be continuous. Differentiability implies continuity. So that means C is gone because it's differentiable but not continuous. Doesn't make sense. Okay, so let's check if it's continuous. The limit as x approaches 5 from the left should be equal to the limit as x approaches 5 from the right. So my left function is this one because x is less than 5. And this is my right function. So negative 5 squared plus 3 should equal negative 10 times 5 plus 28. And look at this. It is not. Oh, wait. It is. Well, that works out. So it is continuous. The function is continuous, so that takes off D. So now it's a differentiable. Okay, continuous. Check. Now differentiable. So we're going to take the limit as x approaches 5 from the left of f prime of x equals the limit as x approaches 5 from the right of f prime of x. So you're going to have to go find the derivatives. On the left side, we have negative 2x. And we're going to go ahead and plug in the 5 already. Negative 2x equals, on the right side, the derivative is negative 10x. No, just negative 10. Do they equal each other? They do. So the function is continuous and differentiable. Okay. We have a dy dx, and if y is equal to 1, when x is equal to 1, then y equals if y equals 1 when x equals 1. Okay. This looks to me like we're going to have to do some separation of variables. So I'm going to start by multiplying dx on both sides. Then I'm going to go ahead and divide by the group by 2 minus y. So that gives me 1 over 2 minus y dy is equal to dx. If I find my antiderivative, I get the natural log of 2 minus y, but there's got to be a chain rule right here. So we're going to multiply times the reciprocal of the derivative. Technically, for the dx, there's an invisible 1, and the antiderivative is x plus c. Now you can plug in your initial condition. Ln of 2 minus 1 times negative 1 is equal to 1 plus c. The natural log of 1 times negative 1 is equal to 1 plus c. That's going to be 0. So c is equal to negative 1. Okay. And now I can go back to my antiderivative, the natural log of 2 minus y times negative 1 equals x minus 1, and I can go ahead and solve for y now. First, multiply by a negative. Then we're going to use e. That's going to be 2 minus y equals e to the negative x plus 1. You can subtract 2, e to the negative x. And I'm also going to go ahead and, no, you know what? Let's keep it because I think I see the answer. Negative x plus 1 minus 2. And finally, multiply by a negative. negative e to the power of negative x plus 1 plus 2. And the answer here is B. Okay. What is the x-coordinate of the point of inflection? That means we have to find the second derivative. So my first derivative here becomes x squared minus 5x minus 14. I'll just go ahead and plug in the x, right? Cancel the integral, plug in the x. My second derivative is 2x minus 5. Set it equal to 0. And solve for x. There's your critical point. Normally, I would go and test it. I would go and test it with a number line. But because this is a multiple choice question and they're telling me what's the x-coordinate of the point of inflection, and I already see it, and that's my answer. Unless we had another option that said none or it doesn't exist, then I would have to go and plug it in to my number line. But it already came up. Okay. Find the derivative. And in this one, we're going to have to use the chain rule. And we're going to have to use the product rule. So it goes the first times the derivative of the second. And the derivative of tangent, the derivative of secant is secant of u, tangent of u, times u prime. Plus the second times the derivative of the first. So looking at my answer here, we have 2x cubed. Okay, whoa. We have 2x cubed, secant of 2x, tangent of 2x. There it is. D. Particle moves along the y-axis. The position is given by y of t, which of the following describes the motion of the particle. Okay. Well, since they're talking about velocity, they're talking about movement, we're going to have to go and find the velocity. So y prime of t is equal to 3t squared minus 8t plus 4. And if I plug in the 1, we get 3 minus 8 plus 4. So my derivative, my velocity is negative. Okay. But at the same time, we need to figure out if the velocity is decreasing or increasing. So we're going to need the second derivative. Y double prime of t is 6t minus 8. And if I plug in the 1, I get negative 2. So since the velocity, one last thing I'm going to check. The original position. Y of 1 equals 1 minus 4 plus 4 plus 3. Y of 1 equals, these cancel. Y of 1 is equal to 4. So if you have the x-axis and the y-axis, the particle starts at 4. And because the velocity is negative, that means the particle is moving down. Really careful with that, because if the particle started on the negative side, oh, I guess if its velocity is negative, it'd still be moving down. So the particle is moving down. C and D are gone. And the acceleration is negative. Since the acceleration is the slope of velocity, that means velocity is decreasing. So the answer is A. Don't get it confused with speed, because in this case, speed is increasing. And that's because velocity and acceleration, they have the same sign. So really careful with that. The question was not asking about speed. Okay. Which of the following cannot be determined from the information given? Well, this one can be determined because all you got to do is flip one of the given integrals. So this one can be determined because you can just factor out the 3, and then you're trying to find the integral of f of x, which is given. So that's actually 24. And you know what? I'll give you the answer for this one too. The answer here would be 2. Okay. The answer is C. And that's because we have no rule for multiplication, but we do have a rule for addition. This integral can be split up into 2 integrals. And then, of course, each integral right here, the integral from 1 to 4 is 8. And the integral from 1 to 4 of g is -2. So there it is. The only one that cannot be determined is C. Okay. 21. For any real number, the limit as h approaches 0. This right here is the definition of the derivative. Okay, the definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. So in other words, there's a mystery function hidden within this definition, and we're supposed to find that function and derive it. If you look at the back part of the equation, that usually tells you what the equation is, because that's f of x. The front part of the equation is f of x, but the x was replaced with an x plus h. And then this right here, that's your x. But anyways, f of x is sine of 2x. So my derivative is cosine of 2x times 2. Which equation has this slope field? Okay. We're going to go ahead and start with the slope field on the x-axis when y is equal to 0. So if I plug in y is equal to 0, I should be getting zeros. This one checks off, this one checks off. This one does not check off because even if you plug in y is equal to 0, my derivative is still going to be x cubed, or whatever x is. And if I plug in 0 into this function, my derivative becomes the absolute value of x, which could change, right, depending on the point. So this is not the answer. Okay. Now, if I plug in any point in this region when y is negative, let's see what happens with my derivatives. dy dx equals, pick any random negative value, -2. Then this becomes -8, which means we have a negative slope. But look at the slopes. None of them are negative. But d actually works out, right? If you plug in -2, the square is going to get rid of the negative, producing a positive slope. So there you go. D is the answer. Okay. Okay, it's a shame I didn't get a chance to finish. I have about 8 questions left, so I'm gonna stop right here since the bell's gonna ring, and I'll finish it in the next part.